So I wanted to do one other example of a homogeneous differential equation. This one, again, it's hard to know, kind of like when we were just learning about integration, it's hard to know when you just see a differential equation what technique to use. Your first attempt should always be to separate the variables. And when you look at this problem, you can separate the variables a little bit, but not completely. The best you could do is rewriting y prime as dy dx, and then dividing by your y value, and also dividing by your x value. So that would look like this. Dy over y equals natural log of x minus natural log of y over x dx. And that's pretty darn close. We just can't quite get the natural log of y to pop over on the left side without it being entangled with an x term as well. So what I'm going to do instead is keep dy dx over here on the left side, keep y over here on the right side, and then rewrite the natural log of x minus the natural log of y as the natural log of x over y. So you can get there a couple different ways. I think the easiest way is just looking at this step here, dividing by x, and remembering that subtraction becomes division. We also have an initial condition. I'll just write it up here because we will use it later. We're not going to use it now, but y of 1 equals 4. So here we have a function now. You can't separate, but I see y divided by x. And so the idea is, well, maybe if I make up a new variable that I just call y over x, maybe that'll be helpful. So now I know that v times x is the letter y, and I know that if I take the derivative, f prime times g plus f times g prime is the derivative of y with respect to x. So I can substitute all this junk for the left side of my equation, and I can substitute this for the letter v, I can substitute the letter v for y over x, and I can handle the x over y because x over y is just the same as 1 over v. So what we have now is dy dx, which I'm substituting as dv dx times x plus v, equals y over x, substituting that as v, natural log of x over y, 1 over v. Okay, great. So then what we're going to do is try to separate our variables and get everything all together. So natural log of 1 over v is the same as natural log of 1 minus natural log of v. I'm also going to bring this v over here. So I have dv dx equals all that times x. So dv dx equals v times, well, natural log of 1 is 0. So I can make that negative v ln v minus v. I've got my x over here. And then I'm going to separate my variables. I have dv over negative v ln v minus v equals dx over x. So the left side can be solved by using a substitution. So let's rewrite the left side as negative v times natural log of v plus 1. The right side is just going to be a natural log when I do its integral. So to solve the left side's integral, I just do a u substitution. I know we have a dizzying amount of letters here. Natural log of v plus 1 So du is just 1 over v dv. So that's going to take care of that v right there. So the integral on the left-hand side becomes du over, cancel the v, so negative 1u. All right, I'm going to move my face out of the way. All right, so here's where we're at. We're going to finish this. The right-hand side becomes the natural log of the absolute value of x plus c. The left-hand side becomes negative natural log of the absolute value of u. So I'm going to move the negative over to the right-hand side, and then I'm going to exponentiate both sides. So absolute value of u equals e to the negative natural log of absolute value of x plus c that I then drop down here in front. Okay, so then I have, substituting back in the u value, natural log of v plus 1 equals, when you have an e to the natural log, you can cancel those pieces out. And so I have a negative power, so I have c times absolute value x to the negative 1. And then I can substitute back in what v is equal to. So that's y over x plus 1 c over absolute value of x. I'm going to plug in the initial condition of x equals 1 and y equals 4. So I get natural log of 4 plus 1 equals c over 1. All right, so I'm going to need to clear out a little bit more space. Okay, we're almost there. So now we know that c is the natural log of 4 plus 1. So here we are. I'm going to get rid of my absolute value. Natural log of y over x plus 1 is c over absolute value of x. Sorry, we just solved for c. Natural log of 4 plus 1 over the absolute value of x. Then I'm going to subtract 1 from all of that. Exponentiate all of that. So y over x equals e to the natural log of 4 plus 1 over x minus 1, and then multiply that all by x. Now there's a chance I made some sort of mistake throughout this process, but let's see what happens when we graph that. The general process is correct, even if there may have been a small mistake throughout there. xe to the natural log of 4. Put that in parentheses just to make sure. Plus 1. That wants me to do another set of parentheses. Over absolute value of x minus 1. Okay, not working. There we go. Okay, great. And does that go through y of 1 equals 4? When x equals 1, it intersects it at 4. And believe it or not, at any point along that curve, this equation here is true, that x times y prime is equal to y times natural log x minus natural log y. Now, I don't know in what situation you would see this differential equation show up, but the idea is that when you can rewrite it in terms of y over x, using this substitution, v equals y over x, can help. You just got to work your way through then a lot of other algebra and calculus to get to a final solution. So please comment and let me know if there's anything that was confusing that I can help with.